Hi, everybody. Just like Mr. Spence said, my name is Brett Burns. I work at Owsley County High School. Uh, I'm also other places within the district, but today I'm talking about a ARI project that we're doing in my classroom with some of the new equipment that we have. Now, like I said, my name is Brett Burns. I'm the technology education teacher at Owsley County High School. I'm actually the best technology education teacher at Owsley County High School. I'm the only one, so that makes me the very best one. One of the things that we've been working on and transitioning in through our county and through our district is that our programs have changed. Our career pathways have changed. Our programs have changed. Now, for my first 9 years in education, I taught in communications. I taught radio, I taught television, I taught graphic communications, and I loved it and it was great and it was fun. But at the end of the day, the information that I was teaching was probably not the most technologically advanced information out there. I ran a FM radio station out of the classroom, things of that nature, and it was great. So when the program changed and we started teaching technology and engineering, which is what I teach now, I moved into more technical aspects and more math-based aspects. We want to talk about that here in a minute, but one of the things I bought for my classroom was a 3D printer. I started the school year out with a 3D printer through our Perkins funding through the state of Kentucky, and it was great. We had a 3D printer. We were printing all kinds of gizmos. We were making stuff, keychains and magnets and all kinds of stuff, but we really wanted to tie that collaboration in. And this is what really wound up happening. In my technology and engineering courses, you can just hammer through this. The main idea was to further learning within technology and really make it more of a technical based course. So we weren't doing arts and humanities anymore. We're moving straight into technology based, engineering based type information. You can go to the next slide. So some of the existing technology that I did have Google SketchUp, which we all have for free. We had access to Autodesk, AutoCAD through our engineering initiative in the United States. All students have access to it for free. We had access to our proprietary software that our 3D printer came with, which is called Z Suite, which is a work path organizer for a 3D printer. And we had software like Blender, which is a 3D modeling studio. And this is all free software, by the way, for public education. But we had all of that in place. Some of the other things that we had were a 3D printer. We had all that quality drafting software. We had traditional rulers, papers, pencils, protractors, straight edges, things of that nature. But we really wanted to push it a step forward. The first thing that we found out when we started working with our 3D printer is we could print 9/100ths of a millimeter resolution, which means 0.09 of a millimeter we could print layer by layer by layer. We could print very precise. So one of the things that we wanted to do was we wanted to enrich their learning and apply mathematics within the classroom. There's a lot of mathematics that we can apply just through drafting and through software, but one of the things that we needed were more tools to go with that. So when we're talking about algebraic notation, geometric principles, things like the Pythagorean theorem, and all that, we could work that within our drafting software all in theory. We didn't need any tools. But then when we started actually designing and building 3D models, and we started doing what's called Boolean algebra and actually taking shapes out of other shapes and modifying shapes, we really started needing to be able to measure things precisely, at least to the precise level of our 3D printer, which meant that we couldn't do that with a ruler, not even the very best rulers that we had access to. So this is one of the things that happened initially in our classroom. I had quite a few students that, yeah, they understand the geometric principles, but we had a lot of students that just really didn't understand it. And one of the things that's going to happen within the classroom is you're always going to have some students that are just doing it and just going with the motions and passing through. But we had a really big problem with students not understanding how to apply those geometric and mathematical principles within the classroom. So that's what I set out to do early on, and that's what my ARI grant was founded on, was the application of that mathematical knowledge. So this was a pre-survey that I gave in class. I had 35% of my students fully admitted, I have no idea what I'm doing when it comes to geometric functions. I don't know how to use them in the real world. I don't know how to apply them. So what we done is I took this data and I really targeted those kids. So I made math relevant in the real world, and the way that we done that is we started building projects that they really had to measure, they really had to do the math behind to develop these real world projects, and ultimately we would print and design real world objects they would hold in their hands. Now, we moved past the keychains and all those little things, the Christmas ornaments and stuff like that very, very quickly. My students moved on to printing technical latches, hinges, 3-part hinges, 4-part hinges, simple machines, complex machines, gear ratios, things of that nature. And when we introduced our grant monies, I need you to go back for a second if you don't care. When we introduced our grant monies, we started using precision measurement tools like dial calipers, and then we moved up to digital calipers and things that could measure at the resolution that we were printing. And what that allowed us to do is when we come back, and I purchased a 3D scanner for my classroom, my students could not only accurately recreate things from the real world, but then they could modify these things to make them better. We could improve technology. So when we were designing a technology system, we could 3D scan an existing object, and we could modify that object to make it better or to overcome specific needs or disabilities or deficiencies that we had. You can go on now. So my students worked on real-world projects, and we used a software suite called White Box Learning, which was already in place in my classroom. We designed things like gear ratios for cars. We designed bridges, structures, survival shelters, prosthetic limbs, rockets, and things of that nature. And for years, even when I was in school 20 years ago, we done that by drawing things on paper, cutting things out on paper, and then it was time to go to wood shop. Well, we have better technology now. We can 3D print all these things. So we're 3D printing nose cones and fins and ailerons and things of that nature for our rockets. We're 3D printing our gear ratios for our mousetrap cars to make them more efficient. And we're using high precision to follow that. And one of the big things that we picked up is we were talking about why and we were talking about how, and when we were making that math relevant. Why do I need these measurements? Why does this work? Any of my kids in my classroom knew if they changed the size of that gear ratio, it affected their speed and their acceleration. But we started talking about why, and we started talking about how, and through White Box Learning and with the help of our precision tools that we bought through our grant application, we really got to a much higher level of understanding of mathematics. You can go on. The tools that we use digital calipers like I talked about, our 3D scanning technology, we had software, and we actually purchased a 3D rotoscopy scanner. Rotoscopy, it's something like that. And our industry standard computer-aided drafting software that we could use in collaboration. So now my students weren't making 2-inch cubes, we were making 1.3 millimeter pins to go in our hinges to replace systems. So it's a very interesting project. You can move forward. And the last thing I want to talk about is how we're going to move forward from here. My students now have, in our Foundations of Technology class, we have access to a scanner and precision tools. We're starting to build that foundation so when they go through my 4-course pathway, we can continue to evolve and grow as students and become more fluent in the use of technology, but also the implementation of mathematical principles. So that's really the focus of my project. That was the focus of my course. And I think in return, not only will it affect my students with making them college and career ready, but it will also affect our classroom scores and our testing scores and things of that nature further down the road. So I appreciate your all's time. I've got 1 minute and 30 seconds. If you have any questions, I'll sure answer them. She has a question. We actually go through the company that we purchased the printer for, and their largest bulk reel is about $30. Yeah. So some of the things that we've replaced with it, we have access. I can customize any keyboard in the building to make it a Braille keyboard instantly. Overnight, I can print those pieces, glue them on. A Braille keyboard costs about 100 times that. So we're saving money by using this in the classroom also. So, any other questions? Thank you.